We've already seen how we can use optical flow to determine where a point in one image ends up in the next image or the next frame in a video sequence. And so optical flow is used to see how every point in the scene is moving from frame to frame in a video sequence. Now we're going to look at a slightly different problem, which is tracking objects or regions from frame to frame in a video sequence. When we do this, you can imagine that we want this tracking algorithm to be insensitive to changes in illumination, in scale, in rotation, and perhaps even occlusion as the object moves over space and time. So that problem is called object tracking. So you want to track the location of a target object from one frame to the next frame in a video sequence. If we can do this through an entire video sequence, you can imagine that we can come up with tracks for each one of the objects of interest and therefore understand how things are moving with respect to each other in the three-dimensional scene. So the first thing we want to talk about is called change detection. We first want to detect what meaningful changes are actually happening in the scene. Perhaps one of these meaningful changes corresponds to a region or a person, an object that we would like to track over space and time. Now, it turns out that this is not an easy problem. There are very simple, commonsensical ways that we can approach the problem, but in order to actually come up with a useful, resilient solution, we need to be able to model the intensity variations at each point in the image. And so we look at the intensity variations as a distribution, and then we fit a model to the distribution. And by looking at these different components of the distribution, we make a judgment as to whether the pixel happens to belong to the background or the foreground. And one particular model we're going to talk about in great detail is the Gaussian mixture model. We take the distribution of intensities or colors at a pixel and fit a mixture of Gaussians. That is to find the set of Gaussians and their parameters that best describe that distribution. Once we do that, we can look at the parameters of these Gaussian, and then for each intensity or brightness value that comes up in the future at that pixel, we can classify it as belonging to the foreground or the background, a meaningful change or not. So with change detection in place, we'll look at ways to track objects over a video sequence. And the first method is sort of a commonsensical method, which is to essentially look at the object of interest as a template in one frame and try and apply template matching to find where it ends up in the next frame. And this template matching problem, we've seen this many times before, can be formulated in a few different ways. The template can be simply an image region, that is a window of brightnesses and colors, or it could be a slightly different representation, such as a histogram of brightnesses and colors. And we'll look at the pros and cons of using these different representations. And then we'll develop an algorithm, which is a very powerful one, that looks at the tracking problem as a problem of first detecting features and then ensuring that those features appear in the object window as the object window translates over space and time in the video sequence. So this is more a local method where local features are extracted, say for instance using SIFT, and then we're looking at the population of these features and where they end up appearing as time progresses in the video sequence. And finally, we'll take a look at a few applications of the tracking problem.